Welcome to the project demonstration of applying wireless sensor network for power consumption monitoring system. So here we are going to monitor the power consumed by the particular loads with help of ZigBee network, and that will be monitored on the PC using hyper terminal application. So here the data is monitored by the microcontroller and also sent through the wireless ZigBee protocol, and the same data will be received by this receiver module, and the data will be sent to the laptop or PC using this USB to TTL converter. Why? Because the data receiving from this ZigBee or microcontroller is a TTL logic data, nothing but transistor logic data. So we need to convert that to CMOS and USB, as the processor can't understand the TTL data. That's why we are converting that to TTL to USB conversion by using this PL2303 converter. So the received data will be displayed on the hyper terminal and will be monitored from here. So for every 1 second the data will be sent from the transmitter section to the receiver section. So coming to the interfacing connections, so we have interfaced this current meter, so to measure the current, and we are going to calculate the power in terms of kWh, kilowatt hour. So that will be done by our PIC 16F72 microcontroller. So we have interfaced this current meter through the optocoupler PC817 IC to A4 pin of our microcontroller. So here the optocoupler purpose is, so on this current meter we can see these 4 LEDs. In that, first LED is a power LED indication and the last LED is a wattage current LED indication. So whenever the heavy load was connected on this meter, then the blinking rate of this LED will be increases faster. Means if it slow blinks, low load, high fast blinking, high load. So based on the blinking rates, our controller will calculate that. So instead of giving the LED output directly to the microcontroller, we placed a optically coupled optocoupler, so in between the LED and the microcontroller. So if is there any high current was generated from this current like LED, then if we connect that directly to the microcontroller, then the main controller will get damaged. So in order to protect that, we place the mediator IC, that's a optically coupled one. So in this one we have the LED one side and other side phototransistor. So when this LED on, inside this also the LED will get switched on. So that other side the phototransistor will get affected, and that will provide the pulse input to the microcontroller. Means same pulse will be converted into the optically pulse and then there to the electrical pulses. So this is the main secure device between the controllers. So only if it is high current generated, then only this IC will get damaged, so that we can protect the microcontroller. So next, so we have interfaced the Bluetooth module, ZigBee module. So this is a ZigBee module which is interfaced at B1 pins of our PIC 16F72, and here also we can see the live data monitor on this LCD screen, so which we have interfaced pin number B2 to B7. So on this motherboard, so 3 major components were placed. One is the microcontroller, which will taking care of inputs and outputs, and a crystal oscillator which will provide the 20 megahertz of crystal oscillation frequency to the controller. So the main purpose of this oscillation frequency is, so we have provided the set of instructions in embedded C language to read the data and to send the data, to display the data. So these instructions will be executed based on the clock pulse from this crystal oscillator. So per instruction controller need 1 pulse. So we are providing 20 megahertz of clock frequency to the controller, so that controller can execute 20 mega instructions per second. So that is the speed of our controller. And the third one is a reset switch. To restart the microcontroller, to reset the reading, just press and release, the system will get restart. So next, coming to the power flow. So here providing 230 volts AC input to this current meter parallelly to this regulated power supply board, so which has the 4 stages: transformation, rectification, filtration, regulation. Transformation to step down the 230 volts AC to 12 volts AC. Rectification to convert the 12 volts AC to 12 volts pulsating DC. And filtration to convert that pulsating DC to pure DC voltage. So from there we will get the pure DC of 12 volts. But we need 5 volts, as our controller and our input and output modules working voltage is 5 volts only. For that purpose we will making use of 7805 regulator, so we will get the 5 volts constant output. So once we provide that to the microcontroller, it start reading input from the optocoupler and provide the output DC output to the through the ZigBee. So before execution in your laptop, so we need to set up the laptop for this application. So for that we need to install the PL2303 application, so which we provide for you. So now this is the application which we are going to provide for you. That's a PL2303. So install this application. So at the end of installation, it will ask for you to insert this PL2303. Insert into the USB slots. So after inserting, now go to this PC. So in your laptop settings, options, go to home and click on this PC and right click on that. So show more options, as we need to go to the device manager. So for that, go to manage and then device manager, and then we can see the ports icon appear here. So this is a common error when we inserting that. So if it is shows like this one, right click on update driver. So browse the computer, let me pick from the list, and then there we need to select the 2008 as it's automatically updated. So but we need to use the previous version. So just that like that we need to install that. That's it. So now we can get the COM number here. So we can see that we got the COM number of 4. So for that USB slot we'll get the COM number 4, right? And now go to hyperterminal folder. So we'll close the previous one, yes and no. So this hyperterminal folder which we provided, and in that, so this is the icon we need to click, the yellow and blue color one. So here 3 settings important. Type any name whatever you want, and then after select the COM number which we got from the device manager, COM4 in my case, and then restore default and then OK. So these 3 are important: name, any name you want to enter, and COM number from the device manager which you got the COM number, and restore default. This is important. And after that this window will open. Now you can switch on the kit. So the devices keep on sending the data, and the same data will be displayed on this LCD screen. So based on the load you will get the this kWh reading varying in faster manner. So right, so we got the 0.003. So how we are going to calculate that? So here the particular optocoupler will provide the pulse input as we discussed. Okay, so here the calculation reading is whenever this particular LED blinks 3200 times, means when the count is reaches 3200 times, then it's assuming it's calculated as 1 kilowatt hour power was consumed by this particular load. So I have calculated the load. So when the count is reaches 3200, so I consume the load of 1 kilowatt hour. So then one blink is equal to 1 by 3200 kilowatt hour. So that's why we are getting initial is 0.003 kilowatt hour. So it's keep on increasing. So when you keep on that increasing, so whenever this particular blinking rate reaches the 3200 times, then automatically it will reaches to 1.00 kilowatt hour. So in this way we are going to send the wireless energy meter data which was consumed by the load in terms of kWh by using the Zigbee communication.